Thank you very much. It's nice to be here. I very much appreciate the opportunity to speak to all of you and to be part of your first OpenStack Istanbul event. As mentioned, I'm John Zannos with Canonical, the company behind Ubuntu. I am also a member of the OpenStack board, as well as a member of the OPNFV board, both driving the adoption of cloud across the world. As Jonathan pointed out, the world is changing very rapidly around us. Very famous quote, very forward thinking back in 2011, that software will eat the world. What that means, as was pointed out earlier, that software is changing how companies run. The great example, Uber, the biggest taxi company that doesn't own a taxi. Airbnb, the biggest hotel company that doesn't own hotels, right? It's changing how businesses operate. And at the same time, the world is changing on how it operates IT. Is going from infrastructure that sat in closets and in data centers owned by companies like GM and BT into this hybrid cloud world. I think when we have this conversation next year or the following year, it'll only be one cloud. It'll be the hybrid cloud. There'll be public clouds like Amazon and Azure and Google mapped into private clouds that exist on-premise, run on OpenStack, possibly VMware, all sorts of solutions. Private clouds that reside in hosting facilities like Rackspace. And these clouds will be mixed and run by end users that want self-operated portals to administrators that are running complex federated environments. This is a bit of a snapshot forward looking on what a hybrid cloud could look like. What is it? It's self-service, it's automated, it's federated, it's across many countries, many networks. In a word, it's complex, but it also represents great opportunity for all of us that are part of this field, be it here in Turkey, be it in the US, be it in Japan, be it in Brazil. The one thing when we are asked to talk to customers that are wrestling with this world, they ask us for our opinion. As Ubuntu, how many of you are familiar with Ubuntu as an operating system? Always good to see a couple hands. It's a little awkward when nobody raises a hand, which doesn't happen that much anymore. They ask us, given that Ubuntu was born for the cloud, born for scale out, what do we recommend? When they talk to us, they recognize that most of the startups in the world, especially in Silicon Valley, Uber, Netflix, Pinterest, they all run on Ubuntu. What we basically tell them very simply is you need to innovate. You need to be ready to change. You must automate. And if you can't do those things, you will perish. You will cease to exist as a company. The marketplace is that competitive. All you have to do is talk to the taxi drivers in Paris, in New York, in LA, in Tokyo that are competing against cars that are run by Uber, right? The world changes very quickly now. So what we talk about in terms of helping people automate, given that we're here talking about OpenStack, is we talk about how do you automate OpenStack? How do you make OpenStack easier? Or at least easy or easier. How many people have deployed OpenStack or tried to deploy OpenStack? Right, we're going to get more hands next year. It's not an easy thing, but all of us in the OpenStack community are working to make it easier. One way we're making it easier is by deploying, hold on, Scott, for a sec. We're going to deploy an actual cloud during my speech with a tool we call Autopilot, which is less important, just freeze one second, less important than what it tries to do. It tries to make the deployment of OpenStack easy. It not only tries to do it, it actually will do it. So for those of you that deployed OpenStack Cloud, sometimes it takes days, weeks. If you have challenges, maybe months. We're going to do it in 25, 35 minutes. What I'm going to do is pick a couple of standard configurations for an OpenStack Cloud. This is an actual live demo, not a tape. Actually, we're going into a data center with an 11-node cloud. First, we're going to pick the hypervisor. Scott will pick KVM. We're going to pick the network, Open vSwitch. This template of autopilot has these decisions made. Scott, raise your hand. He's the man behind the curtain actually running the connection into the data center. We're going to pick the storage, Ceph. All right. And we're going to save the selection, add the availability zones, and okay, save, add, go. Are we started, Scott? There we go, save. I can't, I'm going to fall. It says install. What are you looking? Oh, there is unsaved changes in the region. Configuration to, it's a live demo, completely live. Please either save or cancel the changes. Yeah. Do we restart? All right, KVM, Open vSwitch. Since we're running behind schedule, we'll run a little bit more behind schedule. Second zone. All right, now we start. A little better, but okay. So Scott, if you go back to the slides, we're going to let this run in the background. In 20, 30 minutes, we'll come back to it, and hopefully a cloud will actually be deployed. It'll be deployed with a couple images of Ubuntu, a couple Linux containers, and if it's not working, we'll have a long conversation later. No, it should work. So going back through some slides while this is actually happening, when we talk to customers, we used to talk to them about enterprise and startups. Startups using scale-out architectures, enterprise using scale-up architectures. In a word, from our parlance, when we talk to them, you know, Ubuntu was in the cloud startup world, Red Hat was in the enterprise world, and we had that conversation many times a couple years ago. Right now, when we talk to companies, what we see is a world that actually is scale up and scale out. Appliances that build up like Oracle and SAP as compared to scale out architectures like OpenStack and Hadoop. Why I love that discussion is because that discussion now is happening all across the companies that we talk around all across the world. So a company like Bloomberg in New York City has programs in both. A company like BT in London is doing both. A company like NTT in Tokyo is doing both. If you go to the next one, Scott. Next slide. So when we think about it as scale-out architectures that are really the architectures that are driving growth. So when we talk about companies, they usually don't tell us we're adding 1,000 more machines for an Oracle database. What they're telling us is they have a project with Hadoop, MongoDB, data analytics, cloud architectures. And for Ubuntu, we're in a position where we happen to be dominating that marketplace. The vast majority of development that happens on Amazon, Azure, the public clouds of the world are happening on Ubuntu. The vast majority of OpenStack deployments in the world are happening on Ubuntu. So this is the most recent user data, just to flash it. It's all available on Jonathan's excellent website that the OpenStack Foundation puts together. But this is the most recent data. What's been exciting for us that we've been watching very carefully is how does our position stay over time? Because the market's evolving, people are entering, people are leaving, people are getting acquired. What's exciting for us is this dynamic has stayed pretty stable over the last couple years. But what's really exciting for us and for the whole OpenStack community is that over time, the number of production deployments has increased. So if you happen to have been in the OpenStack meeting that just happened in Vancouver, what was exciting was that we were moving away from a discussion of features and what OpenStack does, and we started talking about users like Walmart, the film industry that Jonathan talked about, that's using OpenStack in production. And what we're seeing in the telecom industry, for example, is OpenStack is becoming the standard thought process for an on-premise cloud. I'll spend a little time talking about what's happening in telecom as a bit of an example. But what's exciting is that we're going from a baby, to a teenager. I think we're about an angry teenager right now, but we're really seeing adoption. If you go to the next one, Scott. So what does that mean, though, in terms of how do we actually have a discussion that's meaningful for a company that's trying to make a decision of how to implement a hybrid cloud? The first thing we actually talk about is what are you trying to do and what are you trying to improve? And you'd be surprised that many companies aren't crystal clear on that. What we use as a primary metric is we say, look, what you're really trying to change is how many machines, how many services does one person in your company run? What does your typical sysadmin accomplish? The average, on average, for the existing industry is they run somewhere between 100 and 200 services or 100 or 200 machines. Kind of maxes out for telecom, financial services, typical enterprises, probably many of the companies here around Istanbul. But when you look at what the future looks like, Amazon, Google, Airbnb, WhatsApp, Azure, Facebook, they're running tens of thousands, hundreds of thousands of services or machines by an individual. For example, Airbnb has 5 people running 400,000 images, 400,000 services. Totally different scale. You only get that scale through aggressive automation, aggressive use of software, as we've been talking about. If you go to the next one. So when we have that conversation, people go, great, what I'm trying to do is take cost and complexity out of my environment and replace it with productive services that make them money, right? Now, what we tell them is that, first of all, you probably commoditized your hardware. You maybe bought some Quanta, you replaced some expensive big iron with small pizza boxes, but that was only a 5, 15, maybe 20% cost savings if you were excellent at it. And everybody has legacy environments. People are still running mainframes. It's not so easy to take all that cost out. The second thing that we say you probably did is virtualization. You're probably running some sort of VM, some sort of hypervisor, maybe ESX from VMware, and maybe Hyper-V, maybe KVM. But at the end of the day, you're taking more cost out because you're putting more services on a physical machine, right? That may be another 25, 30, maybe 35%. What we point out and what we've been having an active discussion, and this is why the cloud is so interesting, we say at the end of the day, if you really want to save a lot of money, you want to operate like Google. You want to operate like Airbnb. And they're not saving their money because they picked a different hardware provider. They're saving their money because they operate at a modern scale-out architecture that is fully automated, that 5 people from Airbnb can run 400,000 images. 400,000 services at the same time. So that's the dialogue we focus on. We're very active in OpenStack. We're running production environments. But when we think about it broadly, we think about it as automation. We think about it as simplification. We think about it as making life easier for a handful of people to do many, many things. Thanks. So it's about automation. It's about simplification. It's about reusing what you've done once many, many times. And that's a very important point. Because many times people think about standing up a cloud and throwing stuff on top of it. But then you want to go beyond that and manage the services you have running on the cloud with the tools you've created and doing things a lot of time. Many times people use Chef or Puppet or Juju or other scripting to do that. But at the end of the day, it's about reuse. It's also about acceleration. All this marketplace is doing is becoming faster and faster. The people that are competing against Uber are competing against a company that adds services all the time. People that are putting Apple or Google on your car are going to do actual updates while your car sits in the garage. Very different model. And then lastly, what we've seen in many of the industries is a big push to open source. We actually use the phrase, and I like to think of it as open core. They're willing to put open source applications, open source platforms like OpenStack, open source operating systems like Ubuntu into the core of what they're doing. Then around it, they're adding value because that's close to their customer. That's how they differentiate. So you may have a company like Netflix running a MongoDB or running SQL open source database. Where they differentiate themselves is the interface between you and them. How do you see the movie? How do you consume a movie? So I'm going to use telecom as a little bit of as an example. And this is how we'll go back to the OpenStack discussion because it's a platform that enables a lot about what I've been talking about. First of all, telecom is a perfect example of an industry under attack. It has declining revenue on its core business. Voice, traditional services that you're used to using when your mother and father used the phone, right? You pick it up, you call another person, that's about the functionality you got. But it was very profitable. Use a phone now, you do a lot of other things, and that's only one piece of it. So the value of that from a perspective of the telecom's ability to bill you for that service of voice has gone down. Data explosion, everybody's consuming their network. Netflix is putting more information across their network than voice ever did. If you look at the recent studies, it shows that in about 5–10 years, more than half the network is just going to be consumed just on video, right? Now, the thing is, if you're a carrier, you still have to make your network bigger. You have to make the pipes bigger to consume all this data. You're not necessarily charging more. And then lastly, new competition. If you followed it, Google just said they're going to lay down fiber, right? They are competing with core telecom services. That changes the environment. If you go to the next one, Scott. So what has the telecom industry tried to do? They've come up with the concept of a network function virtualization architecture, or simply put, virtualizing the network to operate on a scale-out framework. What we've done is figured out how we team with that, and this is why we're participating both in OpenNFV as well as in OpenStack. And I think the OpenStack Foundation has done some excellent work, most recently in Vancouver, trying to bring these two entities together. We see OpenStack as a key component of this, and in the telecom industry, they are treating it as the default selection. You have to be able to deploy and install hardware. You have to be able to lay down a VM or a Linux container. You have to be able to run the different elements of OpenStack compute, storage, network. Then you need to be able to deploy the virtual network functions, which are simply put applications. And we're proposing a tool called Juju, which I'll talk a little bit more about. But you can use Heat, you can use other tools. Then lastly, the two boxes on the top are the traditional orchestration tools. Those tools are the tools that have business intelligence and allow people that know telecom to run the network. SLA, business requirements, billing, operating. And we view that as the part, as I was saying before, that's close to the customer and will not be commoditized. If you go to the next one, Scott. So just as an example, we've come up with an exercise that we are doing with Juniper Open Contrail to simplify this. And this is the theme you'll see from us in the marketplace and our major message around OpenStack is how do we make it easier? How do we package it? How do we bring tooling that makes it really scalable in the same way that Google has operated internally, but the difference is you don't have to hire 5,000 engineers from Stanford University in California and Palo Alto. You can do it with a handful of people and a bunch of very intelligent software. And hopefully a lot of open source software. What I showed before in terms of Maz and Juju and OpenStack, that's all open source software. If you can go to the next one, Scott. So at the end of the day, what we're trying to do is make OpenStack easy with Autopilot, with Maz, with Juju, and I'll talk a little bit about this tooling while I continue to eat up time when our OpenStack cloud is being installed. If you go to the next slide, Scott. So here's at a high level what these tools do. Maz was developed by us as an open source piece of software. Another project is ironic. It's basically something we saw in terms of a need as we were working with customers that were living in the scale out space and had to be able to identify physical nodes, turn them on, turn them off, register them, and ultimately deploy multiple operating systems. It can deploy Ubuntu, it can deploy Windows, it can deploy SUSE, it can deploy Red Hat. Juju is a service model that's designed to weave together different applications, open source or proprietary, and allow them to work together. And most importantly, allow you to scale them up and down, so 1 node to 1,000 nodes to more than that, and also allows you ultimately to be able to say, I want to reuse what I did. I have figured out the best way to deploy OpenStack, and I've done it in Portugal. I want to save that knowledge and share it with somebody else that happens to live in Tokyo. And lastly, if you can go back one, Scott. The Autopilot, which is simply put an overlay on top of Juju, but allows us to make some prescriptive decisioning that simplifies the automation and deployment and management of an OpenStack cloud, which is what we're using right now to deploy our cloud. So we remove some of the flexibility that you have inherently in OpenStack, but we replace that loss of flexibility with a lot more simplification. And ultimately, it's not just a deployment tool, it's a management tool. If you go to the next one, Scott. Back one, I'm sorry. There we go. So we went through it very quickly, but what Autopilot does is gives you an interface, a user GUI, that allows you to have some prescriptive decisioning on what can you do in terms of hypervisors. Ultimately, you'll see our next iteration including Linux containers. What can you do in terms of the network? Currently, we have one. We're going to be adding multiple SDNs. Juniper Open Contrail will be the next, NSX, etc. What type of storage? And we're ultimately going to have multiple choices in terms of software-defined storage. It's basically our ability to make some preliminary decisioning that allows us to be very comfortable that the automation, simplification of the deployment and management of OpenStack allows us to do things in minutes that typically takes days, weeks, and months, depending on the individual's kind of confidence and experience with OpenStack. Could go to the next. So here's some stuff that's on our roadmap. As you saw in the version that Scott used and ran through twice was KVM as the hypervisor. You'll see us bring LXD, which is Linux containers, VMware ESX, Hyper-V via Microsoft, Some of this is proprietary software, some of it's not. Storage from Swiss and Ceph going to software-defined storage solutions that EMC has, ultimately to Luster as well. And then networking, as I said, expanding into a broad cross-section of different SDNs that we know the market is interested in using to figure out how you offset some of the inefficiencies of Neutron. So while Neutron's getting better, you can either use it as an API gateway and plug an SDN into it, or use the functionality that Neutron is able to supply. So creating choice, but not as much choice as you would have without autopilot. So in terms of Juju, it ends up being an actual composition of services or a service model, again, as I said, that allows you to weave things together. And it allows you to integrate things in a way that allows it to be much easier to weave different applications together. This tool was created when we talked to many of the startups in Silicon Valley and said, how do you write software? How do you create an application? And every one of them, the first thing they did was stand up, turn around, and write on a whiteboard. I need a database, I have a web interface, I have this controller, I weave these things together, and this is my code. So what we tried to do is take that knowledge and preserve it and make it shareable, scalable, and be able to reuse it. So this is what Juju looks like. This is a deployment of OpenStack actually with Juniper's Open Contrail SDN connected to it. What this shows is our experience as well as other people's experience on how to deploy and weave together OpenStack in a way that's preserved. This bundle actually, oh, you can keep that for a second, Scott. This bundle is actually available in our Juju Charm Store. Each one of these icons represents the application encapsulated. The lines represent relationships. And what we're able to do is share this via YAML file. So if I created this and I know it works, I can ship it to somebody in Turkey and they can start and use it and then modify it as they need it. But at least you're not always recreating the wheel. If you can go to the next slide. So think of it as this way. Each one of those icons represent an application, a database, something like Hadoop or a Logstash. And the relationships, those green lines, aren't network relationships. They're the relationships defined by the application. Maybe data that they need to access, information they need to access, an application they need to access. So think of this as a live working whiteboard. And that's how we designed it. If you go to the next slide. Then the other part, as I said, was Metal as a Service, which we felt we needed to put in place to solve a need about being able to scale and turn on many, many physical servers very quickly. The things we wanted to preserve is that it can inventory, commission, provision, erase, identify, turn off and on these physical nodes. The fact that it should not be single operating system oriented. All the partners and customers we worked with said the problem we have is I need to be able to deploy Ubuntu, I need to be able to deploy Windows, and this is something that's been crowdsourced because it's a piece of open source software. So an interesting story was the London Stock Exchange actually worked with Maz and called us one day and said, hey, just so you know, I contributed code that allows Maz to deploy SUSE as an operating system. So that's exactly how we wanted it to be used. And lastly, it's able to deploy multiple server architectures. Power, which is now open from IBM, x86, obviously all the Intel architectures, and ARM as well. And when you look at a modern data center, all these architectures are being evaluated if not used. So at that point, we have a kind of working model. We're preserving what we're doing. We're making it available through open source code, and obviously we're trying to automate things so it's easier for everybody. But the question is, how do you have confidence that it works? And this is work we do in collaboration with all our partners in OpenStack and collaboration with the work we do with the foundation, is we've created an OpenStack interoperability lab to make sure things work together when you take one piece of hardware, replace it with another, change one application and replace it with another. Because the important thing about this model, it delivers a vision of things being loosely coupled. It's an architecture that people can use and reference, but they don't want to be locked into any one vendor, any one piece of code. They should be able to use a Ubuntu guest and a RHEL host. They should be able to use a SUSE host and a Ubuntu guest or a RHEL guest. You know, the marketplace is looking for that sort of flexible interoperability. What we've done, if you can go to the next slide, is created a way that in a fully automated fashion, we're able to test multiple iterations. We look at the primary elements of network, storage, compute, and identity. We look at it, how we map it to different SDNs, different hardware, different hypervisors, different storage solutions. And then we do it time and time and time again. And if you go to the next one, we actually currently run 73 different hardware configurations. That allows us to create 175 different types of clouds when you mix and match them. We run 3,000 clouds a month because this is all automated. We run them, tear them down, run them again, real time, mixing things up. We've done 46,000 OpenStack deployments. We've done over 1 million functional tests. But that's how we have a degree of confidence that when we tell somebody, oh yeah, you can put EMC storage with a HP server, with a Ubuntu OpenStack, with KVM, and with a Linux container, and the thing won't break. This is how we exercise it. And we're constantly adding partners every day. And this information we make available to the partners and through the partners to the customer. And this is the information we use as well to help improve how OpenStack works around the world. Now, as an example, one area that we know is actively discussed is the shortcomings of Neutron and how do you bring full network functionality to an OpenStack cloud. We think one of the interesting models is absolutely the SDNs that are being created. What we've done is taken an approach that we're partnering with multiple SDNs and giving them an opportunity to demonstrate their incremental value. And we're mixing things up so any customer can look at them and say, well, I'll try this SDN with this deployment of OpenStack with this hardware, and does that meet my needs? And as I said, we're working with Juniper and others to make this a reality. And this is happening real time. How are we doing on our in progress? OK, we'll go back to the slides. Oh, so when we talk about SDNs, this is actual Juju doing a live deployment of OpenStack, again, connected through the network to a functioning lab environment. Again, the little white cloud ones are the Juniper icons. You can see OpenStack. You can see the relationships that a number of these icons map to the Neutron API. And again, we're using Neutron as an API gateway and bringing the functionality of the SDN to the table. OK, if you can go to the next slide, Scott. So the other thing we realize is that OpenStack as a project has exploded. And there's a couple things that are desperately needed. Like today, in this forum where we're all talking about OpenStack, we need to expand the universe of talent. We're doing everything we can to do that. We've been in the foundation from the beginning, but we're also doing training. We bring our support and professional service organizations to the table, but our real objective is to help make the universe of knowledgeable, trained OpenStack professionals to become bigger and bigger every month. We do that by teaming with the foundation, doing training, helping VARs, system integrators, other parties that are interested, hosters, to become OpenStack knowledgeable. At the same time, we know that that takes time. So we've created a product called BootStack, which is simply put a remote operation model that we're able to run and stand up an OpenStack cloud and then hand it over to somebody to run, or team with a partner in Turkey, in Asia, in EMEA, in the Americas, so they can implement an OpenStack cloud and leverage the operational experience we have. Now, we've been working with many people, and as you saw with the user data, we're in many of the working clouds that run OpenStack. This is just a snapshot of all the types of partners and customers we're working with. The important thing to recognize here is, from an overall perspective, there isn't an industry or a region that isn't strongly exploring and using OpenStack. So all the people that you've seen here thus far today and the remainder of the talks are certainly available to help everybody in Turkey to become more familiar with OpenStack and hopefully help us continue the expansion of the operational use of OpenStack. So at the end of the day, we're trying to do a couple simple things. So if you remember anything else from my talk, it's these three things. One, the objective that will drive adoption is making OpenStack easier. I think we've crossed the threshold that new functionality is less important than simplification and operational experience. Secondly, this is not just automation of deployment. It's automation of deployment, it's simplification, it's reuse, it's sharing of skills, and ultimately it's making it easy to run and manage an OpenStack cloud so you can put things on top of it. Because nobody really cares about OpenStack unless you put things on top of it. I talk to a lot of customers and they ask me what's the one thing I would ask them always to remember about OpenStack. It's the most interesting project that should be uninteresting. At the end of the day, your cloud platform should work like electricity, right? Everybody's worried about the applications. The challenge right now is OpenStack is getting that operational experience. But we're getting it very quickly, and as I pointed out in the telecom industry, it's becoming the de facto standards in many discussions in terms of what you use for an on-premise private cloud. So Scott, how are we doing with the deployment? So, for those of you that ever deployed an OpenStack cloud, that cloud got deployed in less than my 30 minutes. Somebody was timing 29 minutes. Let's look at it for a second in the last couple minutes of my talk, and I didn't really plan it to cut this close to the end. What we have is a cloud based on, oh, go back, Scott. Don't beat me. KVM, Open vSwitch, Ceph, and Ceph. As I said, 11 physical nodes, 2 availability zones, X number gigabyte of RAM. We'll go ahead, Scott. We're going to log into this happens to be the Ubuntu OpenStack dashboard, which is basically Horizon. We'll see what we have in this cloud. So those of you who have been in OpenStack, this is, especially if you use the Ubuntu version of OpenStack, this is what it looks like. Go to the hypervisors, got 11 nodes or so of 11 machines. If you go to the host aggregates, you'll see 2 regions. If you go to the images, on this current cloud, 2 images, 1404, 1204 of Ubuntu. If you go to system information, you'll see the number of nodes and the different, this is what I want to show you. So there's 11 nodes. The 3 lines up top are 3 Linux containers deployed on 1 node. So in 20, 30 minutes, we deployed an OpenStack cloud. Let's give Scott a hand, a little pressure. But it worked. So 19 seconds, if you go to my last slide, right on time, right? Just the slide, Scott, the last slide. So I always end with a story. Hopefully it translates for those of you that are putting up with my English. I apologize. I know absolutely no Turkish. At the end of the day, OpenStack is not perfect. What we're doing is adopting a new market to new technology. So for those of you that don't know this story, this is the story of the 4 hikers. They were hiking through the woods and they came across a bear, very unhappy, hungry bear. At that moment, they all thought they were going to die because none of them could outrun the bear. Then one of them realized, this smiling guy at the end, that he wasn't going to die. He wasn't going to die not because he could outrun the bear, it's because he could outrun his 3 friends. And by doing so, he was good enough to be the best in the marketplace. So I leave you with this thought. OpenStack is not perfect, but it's by far the best solution in the marketplace. What we're doing in terms of automating it and simplifying it is not perfect, but it's by far, we believe, the best way to do that. So if you're going to walk out of any one thing, remember, hybrid cloud is a reality in this marketplace. Some private cloud will be deployed. Don't be one of these 3 guys. Be this guy. And I think you'll be successful because I think OpenStack will have a long, healthy future in the marketplace as being the on-premise open source cloud that's deployed with public clouds and other private clouds in the complex hybrid model I shared in the beginning. I'll be here through the day with some of my colleagues. Happy to answer any questions. I greatly appreciate your time and the hospitality of Istanbul, and I hope to see some of it tonight, and thank you very much.